Good morning, afternoon, or evening, and welcome to this quick little tutorial where we'll walk through this spreadsheet tool I created to go through the numbers and economics of replacing a currently working incandescent light fixture in your home or business or wherever with LED replacement light bulbs. Now, in the year 2023, I expect pretty much everyone is familiar with LEDs, and I know a lot of people probably have the general concept of what they might be able to save or spend down where it's like, okay, LED light bulbs are a bit more expensive, but they save money and yada, yada, yada. But I doubt most people have actually sat down and done the math about how much they would spend and save on LED replacement bulbs over time. And the overtime is an important part. A lot of people probably get caught up on the initial investment was, oh, $3 for an LED light bulb. No way, that's too expensive. Well, light bulbs last for quite a while and they use a resource that costs money, so it makes sense to go over the entire lifetime cost. And so, just going through this worksheet to do exactly that, you have simple 3 steps and 6 entries up here going over the current fixture, hypothetical LED replacement bulbs, and the cost of electricity. And that results in the raw data column over here on the bottom left, which gives running energy consumption in kilowatt hours on the left for both, and the running cost over time in dollars on the right for both. And this goes day by day for 730 days or 2 years exactly. There's nothing stopping you from extending this further 3 years, 4 years, 5 years. But for the purposes of simplicity, let's keep it at 2 years for now. And over here, you have a graph which is basically simply graphing the money over time for both the current fixture and LEDs. So, to go through things quickly, first step is the current fixture, and let's all frame it with a hypothetical. Let's say the master bathroom, 4 lights on each side, 2 sinks opposite sides, let's say 8 light bulbs. What's the wattage of each light bulb? So you go over to your light fixture, you unscrew one of the lights, look at it, and it should say somewhere on there how many watts it is. In this case, house things are usually 60 watts, 40 for smaller light bulbs, but 60 is pretty standard. How many hours is it on per day, the whole fixture? Well, something like in a master bathroom, you maybe have an hour before work, getting ready, cleaning up, taking a shower, etc., and an hour throughout the evening as you go around and do various things. So let's say 2 hours. And right there, you can see the raw data for running energy consumption fill in kilowatt hours. And that's basically how much energy you consume currently on a day by day basis. Going over to the second step, let's think about a hypothetical LED replacement. How much would each LED replacement bulb cost? Well, as I mentioned before, you can get a pretty decent quality light bulb from your standard Home Depot or Sears for $3 depending on where you live. And right there you can see the money start to fill in for the LEDs, going over basically the initial investment. If you have 8 bulbs in this master bathroom and each one is 3, that's $24 in total to replace them all. And what is the wattage of each one? Typically, as a rule, you could probably say that LEDs use about an eighth of the electricity as a standard incandescent, but let's round up and say 10 watts here. Right there, you can also see the running energy consumption of the LEDs fill in, and as you can obviously see, it is much lower. In the graph here, you basically see your initial investment scenario. You bought your 24, and everything right now assumes that electricity is free, but of course it's not. So if you go over here, the final most important step, how much do you pay per kilowatt hour of electricity? You should probably be able to find that out from your electric bill, or you might know it offhand already. And so let's go, I'd say on the cheaper side of things, it's a 10 cents, which is $0.1 per kilowatt hour, and everything comes together. The running cost over time actually starts to fill out for both sides, and the graph starts to make a bit more sense. Here you can see the 2 lines, incandescent in red and LED in blue, and you see the running cost over time for 2 whole years. So obviously the incandescent, you already own it, so at the very beginning it's $0 because you already own it. And the LEDs are in blue. You have to spend a pretty penny just to get them in the door there, so that's $24. But of course, the electricity money, the cost for electricity is obviously drastically different. You can see that in the difference of the slopes, where incandescent is much steeper than LEDs, which allows the lines to cross. And as you can see in this note up here, the day that the lines cross is the day the LED replacements have broken even, where at day around, in this case, 300, so not even a year, this is 9 to 10 months in, the LEDs have cost you over time the same as the incandescents would have if you had just ignored the LEDs entirely. But every day past then, the LEDs end up saving you money. So after the 2 years, the LEDs would have cost you something about $36, which is 24 for the LEDs, and then only $12 for electricity in the master bathroom for 2 years, versus incandescents, which cost you nothing at the beginning, but end up costing you $70 in electricity over the same time. And so you can fiddle around with how many light bulbs, wattages, hours per day, and electricity cost, but just some general guidelines. The number of light bulbs doesn't actually affect the crossover point in time because every light bulb costs money, but every light bulb you replace saves money. So replacing 10 times the number of bulbs costs you 10 times enough, 10 times more initially, but you save 10 times the electricity. So it all breaks even. And for the cost of electricity, it's a pretty linear relation between the payment in electricity and the crossover point. So right now it's 300 days to cross over at 10 cents. If you double it, 0.2, 20 cents, it falls back to 150. So if you double the cost of electricity, the payback time gets cut in half and vice versa. And that should give you everything you need to know to go through this worksheet yourself. Maybe do some hypothetical math with your own bathrooms, house, business, who knows, and actually get some actual answers as far as money and energy savings over time in both cases. Good luck.